quadratic sequences. Now, they're not part of the IGCSE, but they are part of the GCSE, and they are part of the A-level. So it's all useful stuff. So just before we launch into quadratic sequences, let's just remind ourselves of what we do know what to do. What we've done now, up to now, is arithmetic sequences. So what you are used to doing is noting that they are going up consistently by the same number, and that gives us our first part of our expression. We would say 3n, and then we go and do this adjustment where we go and have this imaginary 0th term. So what would be that number at the front? It would be +1, and this is our nth term expression, and from that we can find anything we want. So if we wanted to work out the 100th term, we would do 3 lots of 100, we would add on 1, and it would be 301. So that is something we are familiar with. So the bits I want to sort of draw your attention to, because as we use the language, what we've worked out here with the 3's, that's called the first difference, okay? Where we got the 3, the 3 and the 3, the bit that I've just underlined in yellow, that's really working out the first difference. Okay, it's just the difference between the numbers. And obviously, just to remind you that n represents the position in the sequence. So because I was trying to work out the 100th term, that's position 100, that's why n was 100. So don't lose sight of the fact that n represents the position in the sequence. So that 4 is position 1, that 7 is position 2, the 10 is position 3, and so on. So n is 1, 2, and 3. So moving on to our next topic, this topic, quadratic sequences. I've got one modelled already, and I'm just going to highlight it as I talk it through to you. So the question says the first 4 terms of a quadratic sequence are shown below. What is the next term? So what you do with these, you start off by working out the first difference, how much the numbers are. So for 9 to 13 is 4, 13 to 19 is 6, and 19 to 27 is 8. That is what's called the first difference. Now, you then go and work out the difference between these differences. So you work out what's called the second difference. So what is the difference between 4 and 6? It is 2. What is the difference between 6 and 8? It is 2. So the second difference will be a consistent number. Okay, and on this occasion it is 2. Now, the big learning point, guys, is if the second difference is 2, then you have 1 n squared. If the second difference had been 4, then it would be 2n squared. The number of n squareds is half the second difference. Now, so if you're unlucky enough that the second difference was 1, then it would be half an n squared. So that is the really big take home from today's lesson. Because the second difference was 2, it's a single n squared. Okay, right. So that's the start of our sequence. So we.
Sorry. So the number of n squared is half the second difference.
Yes.
Okay. Thanks.
So it's 1 n squared because the second difference was 2. So what you then go and do, that's your starting point. So go and write out the sequence again, which I've done there in purple, just underlining it there in green. And I'm just reminding myself of the n equals 1, n equals 2, and so on above it, just to help me gather my thoughts. Now, I've just worked out that my first part of my final answer is going to be n squared. So what does n squared give me? So remember, n is the position. So position number 1, n squared is 1. 1 times 1 is 1. That's where that first 1 has come from. Then I move on to n equals 2, and I know it's n squared, 2 2s are 4. When n is 3, 3 3s are 9. When n is 4, 4 4s are 16. Now that is the first part of my answer. Now I need to bridge the gap between what n squared is, right, I'm just popping that arrow in at the moment. I need to bridge the gap between n squared and the sequence I need to arrive at, which is that n, the 13, the 19 and the 27. So the first thing I go and do is, what is the size of the gap that needs to be bridged? So I've just taken away my 1, 4, 9 and 16 from my 9, 13, 19 and 27 to give me the line I'm just going to highlight in, I want to highlight it in yellow. Still purple. Highlight it in yellow. So just make sure you're clear where the 8, 9, 10 and 11 has come from. When I just have n squared, I've got 1, 4, 9, 16, but I need to get to 9, 13, 19, 27. So I've got another 8, 9, 10 and 11 to go. So you've then got to start fiddling around with n's. Now I'm just saying to myself, right, what about if I just added on a single n? What difference am I then left with? So this is a little bit of trial and error, really. So I've just decided to go and add on n. Sorry, I meant to highlight that, not cross it out. I'm deciding to add on n. So go back. So remember, this first number is when n is 1, and then when n is 2, then when n is 3, and then n is 4. And this is me just trialing and erroring with adding on an n. Now, what am I then left with having added on an n? What is the gap that I've now got to bridge? And we're lucky that when we do 8, 9, 10, 11, take away 1, 2, 3, 4, we're then left with just a good old-fashioned number, which is the 7s at the bottom. So there are 3 components to my answer there. I got the n squared, and then I was just fiddling around a bit with n's to see if there was any number of n's I could take away from my 8, 9, 10 and 11, just to be consistently left with the final answer. So that yellow bit and that purple bit have to sort of go hand in hand. You're kind of doing that in your head. You're saying to yourself, if I go and take away n, do I get left with a nice single number? And yes, I did. So I've actually built up my sequence here to be n squared, which I got from halving the second difference. And then the plus n and the plus 7 came from just fiddling around a bit to see where I needed to end up. Now, the question does actually ask work out the next term. If you go right back to the beginning, work out the next term. So the next term will be the 5th term. That is when n is 5. So you just substitute 5 into what the sequence is. So it's going to be 5 squared plus 5 plus 7, which will be 37. So, is anybody, I mean, we're obviously just going to practice this skill now. Is there anybody who wants me just to talk through any particular line there and just sort of describe it by way of colour?
Can you go through how where the 8, 9, 10, 11, that kind of yellow?
Yes, yes. I know that it's a single n squared. So that's my 1, 4, 9, 16. My question is 9, 13, 19, 27. And I'm just trying to build up bits and pieces to get to that 9, 13, 19, 27. And my starting point is that n squared. So simply that first yellow line is just the 2 lines above it in green taken away from each other, because that's still the bit I've got to sort out. The 8, 9, 10 and 11 is the bit that I now need to sort out. OK, and the 8, 9, 10 and 11 is sorted by having an n plus 7. OK,
thanks.
OK, right. I'm sure it's not clear for you all yet. These do take practice. So what I would like you to do, guys, is to let's have a look. Let's just go. What have I done? Yes, now that's not a proper question. No, I want to just go on to one that's like the one we've just done. Right, I'm going to delete all that. Right, I want us all to do number 4 together, please. Okay, so can you go and copy out number 4? All right, so you've got 6, 13, 24, 39, and 58. And we'll do this together. So you just, so the question is, well, basically you can see it's not a, well, work out the first difference first, just to see if it's a normal, easy question. So we've got 7 and then 9 and then, no, we haven't. We've got 7 and then 11, excuse me. 7, 11, 15. Oh my gosh, I've made my pen too big. I can't see my own. Let's just make the pen a bit thinner. So between 6 and 13 is 7. Between 13 and 24 is 11. Between 24 and 39 is 15. And between 39 and 58 is 17. So that is our first difference. You then go and work out the second difference. Difference between the 7 and 11 is 4, 11 and 15 is 4. Sorry, that one on the end I said it was 17, I meant to say 19. And between 15 and 19 is 4. So, because that second difference, is 4, our starting point is to say 2n squared. And that was the bit I said you've really got to learn. So we know our starting point is 2n squared. So n equals 1. Let's give myself a bit more room actually. So what I then suggest you do, once you've gone and worked out what your n squared is, just go and set the scene. So you've got n is 1, n is 2, so we've got 16, 13, 24, 39, 58, and pop above it what n is to help you gather your thoughts. And then just process the first line of your answer, which is this 2n squared. You know that's going to be part of your final answer. So go and take your n, square it and double it. So 1 squared is 1, so that gives me 2. Then 2 2s are 4, 4 times 2 is 8. 3 3s are 9, then 18. 4 4s are 16, 32. 5 5s are 25, 30. And then that's what 2n squared gives you. But I need to go and get to the green line. So what do I still need to fill in? What is the gap that's still remaining? And that's 4, 5, 6, 7, and 8. Now that's nice. That's just really just going up in 1. So all I need here is a single n. Let's change color again. Can people have queries in a second? So let's go, because we're just going up in 1s, why don't we just go and add on an n? I'm already going to put that as part of my final answer. So let's just go and add on an n, which is 1, 2, 3, 4, 5.
So how can we have 32 and then 30?
We shouldn't do. We should have, my mistake, 5 5s should be 50, shouldn't it? Sorry. 5 5s are 25, 2 lots of 25 is 50. Well done, thank you. Should be 50. And 50 take away, 58 take away 50 was the 8. Thank you. So, so I'm just going to go and process a single n because I can see 4, 5, 6, 7, 8. It's just going up by 1 each time, just like n is. So what am I then left with? So what gap do I still need to bridge? 4 take away 1 is 3. 5 take away 2 is 3. And 3 and 3 and 3. So I can see if I then just add on 3, I get where I need to be. So think of it the other way round. Think of it as being your purple line first, then you're adding on the light blue, then you're adding on the black, and that takes you to where you need to be, which is the green. But we're having to do it the other way around by taking away each time. Okay, so at the end of the day, it's purple plus light blue plus black equals the green. But how did we work out all those bits? We had to do it taking away. So we started off with the green, then we took away the purple bits, leaving us with the red bit to go. We did the light blue bits, taking that away from the red, we were just left with that 3 all the way through. So, is there anybody who would like me to explain any particular line on that? So, from the top again, we did the first difference. We did the second difference and we got 4. And because it was 4, we halved the 4 to get our starting point, which is 2n squared. George?
What would you do if your red line was all the same number?
What's the same number?
Yeah, like so where you got 4, 5, 6, 7, 8, what would happen if that was like 4, 4, 4, 4, 4?
Well, that'd be perfect.
What would you do then?
Then there would be an n term. The next line would just be plus 4. So the answer...
so you wouldn't have a plus n or a plus 2n or whatever.
No. In fact,
okay.
I think one of these questions is that exactly happens actually. So that would be great news. If after the 2n squared, the only bit you had to do was bridge a gap of adding 4 each time, then great, just add 4.
Okay, thank you.
And I think that does crop up. That does ring a bell that one of these questions is like that. Okay. Anyone else want me to explain? Yes, Poppy.
So I understand most of it.
Yeah.
I don't know where the 2, 8, 18, 32 and 50 came from.
Okay. So you happy where the 2n squared came from?
Yeah.
Okay, well, I'm just processing that, Poppy. I'm just taking each n in term and doing 2n squared to it. So when n is 1, 1 squared times 2 is 2. So when n is 2, following BIDMAS, 2 2s are 4, then double it, that gives you 8.
Yeah.
And then just do one more for luck. When n is 3, square it and double it, 3 3s are 9, 2 9s are 18. So that line is just processing the fact that we know that line needs to be 2n squared.
Okay, that makes sense. I think when I sort of suspected that, but I didn't follow BIDMAS when I tried to work it out.
Okay, yeah. So basically, the bit that I've just put the red rectangle around on the left, that is then what you apply to the whole row. Okay, that's what you're applying to the sequence, and you're building up your final answer. That first bit there, 2n squared, is the first bit of my final answer. That 2n squared is the first bit of my answer. Then that plus n is the second bit of my answer, and then the plus 3 is the final bit of my answer.
Yeah.
Okay, so let's just do one for luck. I would like you all to have a go at number 5, please. Okay, yes, and this falls exactly into what George was just asking. So can you all have a go at number 5, please? I think once we've done that, we'll wrap it up, because I feel the other bits are self-explanatory. So what I plan to do, just while you're working on this, I will go, because I've done all this worksheet, I'm going to go and send it through to you. I'll pop it on Teams, all the final answers on this. I suggest you just read through this, all right, checking you see where all my answers came from for the whole of this Corbett maths. When you feel comfortable with that, I would suggest you then go and do the Dr. Frost questions, okay? So don't spend your time working through all of these. I've done it for you. You just go and copy my answers down. Sorry, you just go and read my answers and check you see where it all came from. Joe.
So to find the n value, is it just trial and error?
Yes, whether it's 1n or 2. Yeah, I think basically if you're going up, because remember n goes up in ones, doesn't it? N goes up in ones. So if you can see that the bit that you got there in red, like on that previous one, I'll just go back to it. You know, the 4, 5, 6, 7, 8 on that one, because that's going up in ones, you're only going to need to have one n. If that was going up in twos, then you'd probably have two n's.
I was just saying, if it was going up in like 8, it would probably be 8n.
Yeah, I think so. I to be honest, I haven't done a huge amount of these recently myself. I would imagine if they, yeah, I think so, because that's going to give you something that's going up in 8s, and then you're just going to have to do that final adjustment of the final number. So yeah, I think that's going to work as a rule of thumb, Joe.
Okay, thank you.
I must admit, I'm a bit rusty on this myself because it's not part of the IGCSE, so I haven't done a lot of these myself for the last 5 years or so. But I think that's right. If the red bit there is going up in ones, just try plus n. If it's going up in twos, try plus 2n.
Okay, thank you.
For the second diff bit, and I highlighted it in orange. If it was 10, then would it be 5n squared?
Yes.
Okay.
Poppy.
Oh wait, that's from before, sorry.
Okay. Right, I'm going to start working through this one as well. Yes, so this is Joe's point. Because we're going up in 6s here, try 6n. Oh no, yeah, it was yes, that was Joe's point. I was getting in a muddle. This isn't the one that George was saying. With this one, there just isn't any of that final number. I knew there was one of them where you didn't have 3 components. So, as I said, I think that really covers all the critical skill. So what I suggest we call it a day now. I'll stop the recording. I will immediately go and save this, transfer it over onto PDF and upload this over onto Teams. And as I said, I would suggest you prioritize reading through this when it comes through in a minute, just flicking through all the pages. Once you can see what's going on, rather than do work on this Corbett Maths, I would suggest you just do any practice you want to do on Dr. Frost. Okay, just before you all disappear, I think it was Victor might have mentioned it, or somebody did. You've probably assumed it. We're not having any further maths testing as part of this check-in testing when we go back in 2 weeks. I just don't think we got through enough of the syllabus. Okay, so Mr. Smith hasn't asked us to do, so I'm sort of keeping my head down. The way I see it is we should pretty much have finished the syllabus by Easter, and then we'll just do some sort of testing in the summer term. Right, I'm going to stop the recording there, guys. Obviously, you're welcome to hang on and ask me any questions if you want, but you're equally welcome to go.
Thank you.